All right. Hello, everyone, and welcome to Easy Pathfinding in GameMaker. I'm Josiah, and today we're going to learn how to use paths to make objects navigate around a level while avoiding obstacles. To do that, we'll start by having a look what paths are and how to use them in GameMaker, and we will then have a look at three different methods of motion planning, starting from the simplest one, which only requires pretty much 2 lines of code, and ending with a pretty powerful grid-based pathfinding method that will allow your objects to navigate even the most complicated level layouts. We'll be using GML code for this, but don't worry, the code is not going to be super advanced. The functions we'll be using are quite straightforward and easy to use even if you don't have a lot of experience with coding. If you do have any questions while watching, feel free to ask them in the chat. I will try to have an eye on that, and also at the end we'll have like a bit of a question and answer session. As always, the project will also be available for download, so you can have a look at the code yourself. I will just go ahead and paste the link in there. You don't have to download it now, but at some point after the session you can check in there and see what we did today. So before we're going to start, let's just have a look at what we will be making today. So I'm going to hit play right here. And this is basically the project that we're going to make, this little Eggman that is standing around. And if we click anywhere on the map, it will navigate there while avoiding the walls. And you can see like which path it is going to take. And as you can see here, even if we click somewhere away that's like a little difficult to get to, it will always find like the shortest path to get there, and then we'll start walking there by itself. That's pretty much what we're going to do today. For now, let's go ahead and just delete this object again, because we do want to start from 0 pretty much. So I'm going to go ahead and delete this and just create a new object and make this egg learn how to walk as well. I'm going to go ahead and give this the proper sprite and then put it back in the level again. Oop, that's the wrong layer. Over here. And now, first off, we're going to have a look at what paths are, because paths are something that not a lot of people maybe have used before in GameMaker, and it's basically just a collection of points that are connected to each other and that you can use to tell your objects how to move around the room. So I'm going to go ahead and just create a path right here. And as you can see, it opens up like this little grid editor, and you can just go ahead and click in there to place points on the path, which we can then later on use to tell our objects to walk along this line. You have a couple of options here. You can change between these straight lines or having a smooth curve for a little less of robotic looking movement. And then you can also change between an open path like this that has like one end and another end, and a closed one, which just means that both of the ends are connected, so it's a loop basically. Alright, but editing it like this is a bit not so perfect for our scenario, because we actually want to see what it looks like in the room. So I'm going to just go ahead and delete all of these points again and instead go into our room editor, because we actually have the opportunity to create a new path layer in here and then edit the path right on top of our room, which is a lot more comfortable than editing it just in a black void. So I'm going to go ahead and just put this path in here. No, I'm going to click here and then I'm going to select this path. And now I can add points in the level directly, and I will see where they are in relation to all of the objects in the room. So I'm going to go ahead and just create a very simple path for our Eggman to walk, maybe like this. And you can always add new points between other points by just clicking and dragging between them. And I'm going to go ahead and make it like this. This is pretty simple, but for now it's just going to be perfect to show how it works. And then to have our egg walk along the path, we just need one line of code, which is going to be in the create event of our egg. We can tell it to start walking along the path by using the method pathStart. And then we'll provide our path name, which in our case is path1, the speed at which is going to walk along the path. I'm just going to do 2, which means that it's going to walk 2 pixels per step. And then we have to provide an end action. And this basically tells the object what it's supposed to do once it reaches the end of the path, because there are several options that it can do, and all of them start with path action. And you can see here it's 4 different ones. So stop is pretty self-explanatory. If we put this in here, it will just stop after it reaches the end of the path. Reverse means it's just going to go back and forth between the end and the start. So once it hits the end, it's going to go back and keep going back and forth. Then we have restart, which just puts our object back to the start of the path and then just starts it again. And then continue, which is a little different from restart because it means that it will start the path again, but from the current position in the room. So if we have a path that is not closed, the end position is going to be different from the start position. And if we use continue here, then it would just start from there again and continue the path in a different direction. So in our case, we can just use restart because our end and start point are the same. So restarting will just keep the path moving. And then the last argument is whether or not we want our path to start at its position in the room or relative to our object. So if we were to say we don't want it to be absolute but relative, then it would actually move this path so that the starting point is where our object is. In our case, we don't want that. We want our egg to actually move between these positions in the room and not to move the path around. So we will leave this as true, like that. And that line is all we need to have our egg walk around the room like this. And it will just keep going. Once it reaches the end, it will just walk in this circle. So this way of just creating paths in the editor and putting them in the room is good if you have like patrolling guards or some obstacles in your game that are supposed to move along a certain pattern, and you can just put it right into the room and tell them where exactly they're supposed to go. But it doesn't really react to anything, and it's not very flexible. Like, it doesn't really allow us to move wherever we want to. But that's what we're going to do next. And for that, we will have to actually create a path within the object itself. Because if we want our egg to go wherever we click, we can't really predefine that in our editor. We will have to have our object decide where the path is supposed to go. And for that, GameMaker has 3 different functions. The first one is pretty simple, and that's what we're going to start with. And that is called one second. We're going to add a mouse event, a global left press mouse event, and then we're going to add this function, mp linear path, and that will create a path from our current position towards a goal position while trying to not collide with certain objects. So first of all, we're going to have to provide a path for it. And technically we could use the path that we already created here, but it's always good to have our own path within the object, because if other objects are trying to use this path and we manipulate it within this object, then the other objects will become confused and use a different path as well. So we will just create a new path in here that we're just going to call path. And we're going to do that by using this method that's called path add. And then we can use this method to set the points to the right positions in here. So yeah, that's the first argument, the path that we want to manipulate. Then our goal position, which in our case is going to be the mouse X and mouse Y position. Then we have to provide the step size. And this basically how the function works is that it starts at a certain position of the object, and then it goes step by step closer into the direction of our goal position until it either reaches the goal position or it reaches an object that it collides with, and then it stops the path there. And the step size basically tells us how big these steps are supposed to be. So in most cases, if you want an object to walk along the path, you should use the same walking speed as the step size, because that's going to bring the best results. So in our case, we will use 2 here as well. And then the last argument is going to be if we want to check for all objects collision or if only for solid objects. In our case, we don't have a lot of objects. We only have this object wall here, which is empty, and our egg. So in our case, it doesn't matter if we check for all objects or only for solid objects, but if you have different objects in your game, like walls and then certain other objects that you're not supposed to collide with, then it makes sense to flag your objects that are supposed to be collided with as solid, and then in your object, don't use check all, but check only for solid objects, so put false here. So this will create our path towards the mouse position, and then one last thing that we have to do, we will just have to start this path again, and that we will do with path start as before. And this time we're going to use this path that we just created. I'm going to use the same speed of 2. The end action at this point is going to be path action stop, because we don't want our object to continue once it hits a wall or reaches the goal. And then absolute, we're also going to put to true. Now with these lines, we will already have a behavior for the object. Well, it will start again with the path that we predefined, but once we click somewhere, it will start moving in that direction. And you can see if I click over here, it will just only move towards the walls and then stop. It doesn't really avoid it at all yet, but it's a super basic way of movement and not getting stuck in any walls or obstacles. Now, one more thing that's super useful going forward is I'm going to go ahead and add a draw end event in which we can put some debug code so we can actually see the paths that are generated. Because one thing about paths, especially if you generate them within the object, is you can't really see them per default. So this function is going to be super useful. And it's just draw path. And we just want to draw the path that we're currently on. So that is always saved in path index. And we want to draw it in the 0, 0 position in the room and absolute. And this will draw the path that we're currently on. One more thing about this, if we are not currently on a path, the path index variable will not return a path, so this would actually crash. and return an error. So we will just go ahead and put one if here, and we will just ask if path exists, path index, and if it doesn't exist, then it won't draw anything because there's nothing to draw. So if we click here now, we will see that we can actually see the paths in the level, and if I click somewhere, these are the super straight, super boring paths, but we can actually debug a little easier with that. Now, the next method is a little more like actual pathfinding, because it doesn't just make a straight line. It works pretty similar to the linear pathfinding though, and this one is called MP potential path. And we're just going to go ahead and delete this. It has similar arguments though. At first we're going to provide the path that we want to manipulate, then our goal, which is going to be once again mouse X and mouse Y. The step size is going to be 2. And now how this one works is, instead of just going towards the goal point and stopping once it hits a wall, it will, if it hits a wall, it will check on either side, like a little more to the right or a little more to the left, if it finds a way to get closer to the goal. And if it does, it will just continue along around the object until it can go back towards the actual goal. And the thing about this is that not always will it actually find a path to the goal, but it can get stuck in certain areas, or maybe the goal, there's no actual way to the goal and it can't reach it. So to prevent our pathfinding method from like just infinitely looping around somewhere, we can provide a factor which basically tells our function how long it should try to find the goal. Like, for example, if our distance between the object and our goal is 100 pixels, and we provide a factor of 2, it will try to find a path until it either reaches the goal or until the path is 200 pixels long. So like the distance times the factor that we give here is the maximum amount that it's allowed to take to reach the goal. Basically how much of a detour it's allowed to go before it just gives up and says, okay, I can't actually find the goal, I will just stop the path right here. And usually this, like 4, is a good value for that, because if the algorithm hasn't found the goal after like 4 times the distance, then it probably won't reach it, because it's stuck somewhere, or the goal just isn't reachable at all. And then once again we have a check all here, and we're just going to put false to only check for solid objects, just like that. And the rest is the same. We also have to like create a path in the beginning and then start it afterwards, but just this method is a bit of a different one. And just like that, we can use this one, and you will see that it already can avoid these very basic obstacles here. It will find a way to walk around them and still reach the goal. Now, the problem with this method is that it can't really get to advanced places like this. Like if I click here, you'll see it will try to find a way to get there, but will just get stuck in here because it can't really figure out how to get there. It works, like to a certain extent it works, but if it's too far away and if the level is like too complex, it will just have trouble getting there. So it's good for like if you have like rocks in the terrain, or if you just want to avoid running into other enemies or stuff like that, it's perfect for that. But if you have like a maze-like structure or even like different rooms and stuff, this is not the perfect way to go. For that, we actually have the third method, which requires a little more of a setup, but how it works basically is that it overlays a grid over the whole level and then marks certain cells in this grid as blocked, as like non-passable, and other ones as free. And then it uses an algorithm to calculate the shortest path between any 2 points on the map. And that algorithm, like if you're interested in how it works exactly, you can look it up under the A star algorithm. It's like A and then the star symbol, or you just type A star algorithm in there and you'll find a lot about it, because it's a very popular pathfinding algorithm that is quite efficient and powerful. But to use it in GameMaker, you don't really need to understand the math behind it, because the functions are quite easy to use, even if you don't know how it works exactly. So to do this, we will actually have to go ahead and create this grid before we can calculate any paths on it. And we do that by starting with the mp grid create. And there we have a bunch of arguments that we have to provide. The first ones are just where the grid is supposed to be positioned. In our case, we just want the whole map to be covered by the grid, so we want the position of the grid to be 0, 0, which is like the upper left corner. And then we will have to provide how many cells it's supposed to be wide and how many cells it's supposed to be high. And for that, we will first of all have to know how big our cells are supposed to be. In our case, since we already have like a grid in the game by itself, like even in the room editor, we have this grid that here it's 16 by 16 pixels, and that is perfect. If you have a grid-based level structure, you can just use that grid size for this grid as well. So we will just go ahead and create a little variable to save our grid size. Grid size is 16. And then to get the number of horizontal cells in our level, we can just divide our room width by the grid size. So we will put room width divided by grid size, and that will give us the horizontal amount of cells on the grid. And then we will do the same for the height, which is going to be room height divided by grid size as well. And then we have to provide the dimensions of the grid, of the cells, which are also grid size and grid size. I'm just now noticing that it should be cell size instead of grid size, so this is not actually correct, but let's just quickly rename these so it's not confusing. It is the size of the cell and not of the grid. So this basically creates the grid, and then one more thing that we have to do with the grid is actually fill in the grid with the cells that are blocked and the cells that are free. Like per default, all of the cells are going to be walkable, and now we just have to tell our grid which cells should not be walked on. And to do that, we can either do it manually and like put in certain values that should be blocked and not, or we can just tell it to check for collisions with objects. In our case, we just want all of the cells that are that contain one of these wall objects to be blocked, and we can do that by using mp grid add instances. We provide the grid here, which we will actually get if we put it in a variable before creating it here. And then we provide the object wall that is supposed to be blocking the cells. And then if you have like objects that are shaped in a little more complex ways than just rectangles, or they're rotated and scaled weirdly, then you might use the precise argument in the end. For our case, since it's just rectangles, you don't really need that. You can put it to false. And this will pretty much create our grid, so we can use it for pathfinding. And for the grid, just as well as for the paths, we have a useful function that allows us to actually see the grid overlaid over the level, so we can check whether or not it's working as it's supposed to. And the function for that is mpGrid draw. And then we just put the grid in here. We will have to lower the alpha value before that, because otherwise we can't see the level below it anymore. So we will just go ahead and use draw set alpha and set it to 0.3, just so it's a little translucent and we can still see the level below it, and then set it back to 1. And if we press play now, we will see these red tiles are the ones that are blocked, and they pretty much one-to-one overlay with the objects that we have here. Now, one thing to note is if we move our objects like in between the grid here, if we, for example, were to put our wall here, note that if we start it now, it will block all of the cells around it. So if you're working with objects that aren't placed on a grid, you might want to make your cells a little smaller, so it's more accurate around the actual objects, because like this you could block a lot of space just because of the placement of the objects. For our case, it's not a problem though, because all of it is on the grid. And now we can go ahead and actually have our object walk along a path that is generated with this grid. Once again, we can use these two, because we still have to create a path and then start it in the end. But this time we're going to use yet another function, which is going to be mpGrid path. And once again, we will this time start with the grid that we want to use as an argument. Then we will start with the path that we want to manipulate. And this time we will have to provide both the start and the end position. The start position is going to be the position of the object itself, so x and y. And the end position is just going to be mouse x and mouse y once again. And then the last argument is whether or not we want to allow diagonal movement. And for our case, that's totally fine. If you have a game where objects are only supposed to walk like horizontally or vertically, then you can put that to false, but we're going to go with true here. And one more thing with this one, which is different to the other two, if this one does not find a path, so for example, if the endpoint is either within a wall or it's like completely walled off, so there's no path to be generated, it will not actually create a path. And then we would have a problem if we try to start this non-existent path. So once again, we should put an if before this, because this function actually returns true if a path is found and returns false if there's no path found. So only if this path is actually created do we want to start the path. And just like that, if we try it out now and click somewhere in the game, it will create this path and start walking towards that position. And this one is pretty perfect in its pathfinding. Like if there's any way to find a possible path to another point, then it will find it no matter how big and complicated the level layouts are. And that's the great thing about this algorithm. Now, one more thing that we can do to make this one a little prettier is to change the path from using these straight lines to using the curves as we did before in the editor. We can also do that with code, and to do that we use path set kind, and that changes between the straight lines or the curved lines, and we provide the path and then the kind, and 0 is straight lines, 1 is curved lines. So if we put this in here, it will make our path look a little more smooth and less robot-y in its movement. And just like that, we have our egg walking to wherever we want it to go, just like the project was in the beginning. That is pretty much what we wanted to achieve. Now, one more thing that is important to think about when doing pathfinding is a lot of times you will want your objects to follow a certain object or to change and adapt to moving parts in the level or stuff like that. And that is where the previous two pathfinding methods have a bit of a advantage, because they are a lot less performance heavy. So this one, while it's great and it can find paths from everywhere to everywhere, if you were to generate a new path every step or every time you have like some object moves around, you have to recreate the whole grid, and then you have to calculate a new path and start it. And then if you have like maybe not just one object doing that, but like 10 or 15 or however many, it will impact your performance pretty quickly. So that is a little bit of a problem. But the other two pathfinding methods actually have like a bit of a good solution for that, because instead of calculating the whole path, you can also only calculate the next step and then use that step before calculating the next step. So it's a lot easier on the performance. I'm just going to go ahead and show this real quick by creating a second egg here. And this is just a simple one-liner. We can put it in the step event instead of the click event. Like if we were to want our object, for example, to just follow the mouse constantly wherever we move, not just on click, then we will put it in the step event. And right here we would put MP potential step instead of path. So if we put this here, it will, instead of creating a path and then starting it, we can skip that, and it will just create the next step and move it in that direction. This one would be mouse X and mouse Y once again. And then our speed is going to be 2. And we want to only check for solid objects, so this would be false. And just with this, if we put this in the game now, let's delete this one and put our second egg in here, you can see that it will already move and follow the mouse wherever it goes. Still, it will get stuck if it's too far away, as with the previous method, but otherwise it's exactly the same thing. It's just a lot easier on the performance because it doesn't recalculate the whole thing. If you want to use the grid-based method on moving targets or with moving obstacles and stuff like that, you will always have to think about how often you can actually recalculate it. So, for example, if you wanted to follow the player or something, it's a good idea to only update the path every couple of steps instead of every steps, or only update it once the player has moved away from its last position by a certain amount, or stuff like that. This is very dependent on your actual project and how you can implement that without it actually impacting the pathfinding. But there's usually a solution you can find for that. So yeah, that's pretty much how you can do very simple pathfinding in GameMaker. That's what we wanted to do today. And if you have any questions about what you saw just now, you can go ahead and ask, and I will try to respond and answer any questions that you have. Otherwise, yeah, as mentioned, there's the project to download should still be somewhere in the chat. It will also be in the description later if this is the video. And that is pretty much it. For multiple pathfinders. So let's, with the questions, let's stick to the general topic of pathfinding. That's going to be probably more useful for people watching right now. For multiple pathfinders, moving towards players can use a slow loop sort of idea, so maybe only update the path for... yes, that is, like if you have multiple pathfinders, it's a good idea to actually offset the update. Like if you, for example, only want to update your path every second, like every 60 frames, that's a good idea by itself. But if you have multiple objects, it's also a good idea to not update all of them at the same time. So have like one object update, then the second object update 2 frames later and stuff like that. So all of the workload and the performance heavy stuff gets like spread out over multiple frames and doesn't just slow down the game once every 60 frames or something like that. Why does the object sometimes go through the walls? It should not be going through the walls. Let's try again. It goes like kind of behind it because the collision mask is a little smaller than the actual sprite of it, but it doesn't actually go through the walls. It just hides behind them a little bit. Yeah, all right. So if there are no other questions, I'm just gonna go ahead and wait for another minute or so. But if not, then oh, you don't mean in the stream. Okay, in your project you're having collisions with a full collision mask and my object's going through. Yeah, I'm not sure what kind of method you're using and what the problem there is. But yeah, if you use these functions, it technically shouldn't happen. Like maybe if you're using the grid-based pathfinding and the grid isn't updated and you move objects around there without updating the grid, maybe that's leads to the object walking through walls or something like that. I'm not sure. Have you considered making an RTS using this technique? What issues would you find with using this method? I myself, well, I think it would be a good method to use for RTS. Like I haven't planned on making an RTS yet, but it is good. I think mostly like if you're trying to work with multiple units with pathfinding, then you will have to kind of it's a good idea to actually use a bit of a mix between two of these functions, because one thing that the grid-based method is not very good at is updating with like, or trying to avoid other instances, because you would have to, whenever an instance moves around, you would have to recalculate the whole grid, which is a bit of a problem. So for an RTS, I would suggest that you have a grid with everything that's static, like buildings or like any obstacles, and then have a sort of an invisible pathfinding helper for each object that basically tells it where to go along the path, and then go towards that position, but uh, go there with using this potential step instead of um, the grid-based path itself, if that makes sense. Because this one, it's very easy to use for avoiding other instances as well. Like if we can actually try this out. If we have a bunch of these eggs here that use this method, they will, and if we tell it to avoid not just solid objects, but also non-solid objects, they will also try to avoid each other, and they will actually not collide with each other. Which is great, because if we were to do that with the grid-based pathfinding, eventually all of the object would just overlap with each other because they ignore each other while doing the pathfinding. The tricky part is positioning multiple units. Yeah, I mean, if you have something like you want your objects to walk in certain formations or stuff like that, then you would have to find a way to make your units actually go to the position that they're supposed to. But that's like a very specific problem that, like, it depends on what you're actually trying to achieve, and then you will have to look at which methods are best for achieving that. But yeah, as I mentioned, like if you have multiple units, it's a good trick to actually have a bit of a mix between this method and the other method. Some RTS games have units no collision when units are too clumped. Yeah, I mean, if the more instances you have, the more complicated it gets to have the pathfinding work for all of them, and then also um, for them to not get stuck on each other and stuff like that. Yes, actually, also if you have overlapping units, that's, I hadn't thought of that, but actually, if you were to just slow down one object so it doesn't collide with the other ones, that's a good solution as well. Potentially, you would just have to find a way to decide which one to slow down, so you don't slow all of them down, because that would be a problem. But yeah, that's a good one actually. All right, so I guess that's it with the questions. Thanks everyone for watching. I hope this was useful for some of you, and stay tuned for future webinars. I'm not sure what I'll be doing next, but there will be others as well, talking about different topics and different experience levels as well. But yeah, have a good evening or whatever time of day it is for you, and happy game making.